Section 1.2.3, connecting limits and graphical behavior, is really just additional practice to what we've been doing on this section here. So which limit expressions agree with the graph? So you can tell it's just going to be reading through these and seeing which ones agree with it. So if you look at this, limit as x approaches 2, you see how it's going down to negative infinity from both sides? So the limit as x approaches 2 from the left, this time it's from the left, if you see that little minus sign, I'm not sure if you can see it through the recording, is unbounded. Yeah, well, from the left side, it's unbounded. It's even unbounded from the right side. So yeah, this one checks off. So once again, you can see as we approach it from the left, it's unbounded. It's going down to negative infinity. Let's look this time. The limit as x approaches negative 4 from the right. So as we're approaching negative 4 from the right, that's right there. This spot right here is 2. Well, yeah, it is 2. So that checks off. What about the limit as x approaches 2 from the right? As x approaches 2 from the right, yeah, that's also unbounded. Remember we said that earlier, it's unbounded from both sides. So all of these would apply. Over here we get another one just like it. So the limit as x approaches 1 from the right. So as we're approaching 1, here's 1 right there. So from the right, as x approaches 1 from the right, is negative 5, right? If you look at that y value, that's not negative 1, so this one's out. The limit as x approaches 4. We got to check both sides. So from the left, it's approaching negative 3. And then also from the right side of 4, it's approaching negative 3, that same point as well. The actual function is 3 up here. Remember, we don't care about the actual function when we talk about limits. We care about what it's approaching. In this case, it's approaching negative 3. Well, this one's saying that the limit equals 3. No, the limit doesn't equal 3. The limit it's approaching right here, negative 3. So that one's also out. Then the limit as x approaches negative 1 from the right, so as we approach negative 1 from the right, is 1. Now I'm getting this one mixed up. Negative 1 from the right, I was thinking positive 1. So negative 1, this one was positive 1, so we did that first one correct. But this one, negative 1 is right here, right? So from the right, we're approaching positive 1. Yeah, because look at the output there. The output there is positive 1, so this one checks off. So these colors are going to look chaotic if you try to look at that without watching this video. Let's look down here. Which graphs agree with the statement? So we're going to look for all graphs that have the limit as x approaches negative 2 equal to 3. So as we approach negative 2, well, the limit doesn't exist because look, the right-hand limit and the left-hand limit are different. So that limit doesn't exist. We want it to equal 3. Over here, it's unbounded. Both ways unbounded. This one is blowing up to infinity. This one's going down to negative infinity. That's unbounded, so that's out. Let's look at this one. As we approach negative 2 from the left, it's 3. So from the left, it's 3. And then also from the right, it's 3 as well. See, as we approach negative 2 from the right, well, our output's getting close to 3. So this one, it checks off that statement. Makes that one true. Last one, we want to look for whenever the limit as x approaches 3 equals 5. So let's look at this one. As we approach 3, from the left, it's going up to 5, so that's good. And then also from the right, it's going to 5 as well, so that one's good. Now you got to choose all. So we need to double check all the others. This one from the left is 5, from the right is also 5, so that one checks off. And then last, this one also from the left and from the right, as we approach 3, is 5 as well. So that checks off. And there you have it. That's limits using a graph.